Alright, so over this past week, we've been dealing with geometric sequences, finding or recognizing them, extending them, and then finding the nth term of them, right? So we're going to be moving on to the next section of the lesson, so 9.2, and this is dealing with exponential functions. And I know it sounds scary, but it's really not, because it's really close to what we've been doing this past week. So first things first, an exponential function is a function where the independent variable, or our x, is in the exponent, or appears in the exponent. And having the pen is usually helpful.
What goes in the other line?
What
goes in the other line?
Before that one.
Yeah, there's a little.
In another film, like,
Because our independent variable is usually x, right? Right. Right, so when we look at exponential functions, or when they're giving you in your homework, they'll have the basic form of a b to the x. So that's just the general form. And right below it, it says where a is not equal to something, b is not equal to something. So what do you guys think would go in there? What could a not be equal to?
X, 0.
0. Josh says 0.
1.
And why would that be? If a were 0, what would we get for an answer?
0.
0. So functions usually have lines that go on forever, right? So if we just get 0 for every single entry that we put, all our line is going to show is just 0. So that's where a equals 0, b cannot equal 0, or excuse me, a cannot equal 0, b can't equal 0, and where b is greater than 1. Nope, not 1. That should be backwards. 1, 0. I'm sorry. All right, so a is the value, or a, because it's a times b to taken to some power, right? So a is the value when x is 0. So if we were to take b to the 0 power, what's b to the 0 power?
0.
0? Something taken to the 0 power is 0?
go ahead, try it on your calculator.
Yeah.
Is there?
Take something to the 0 power on your calculator, but don't take 0 to the 0 power because I don't think it'll work. You can try it, but
Yes, right.
Wouldn't it be with just 1?
Hmm?
It would be 1, wouldn't it?
Would it?
it says
Yeah.
Yeah, it says 1, so take something else to the 0 power. Like, just take a different number to the 0 power. What do you get?
1.
0.
Still get 1. So if we take b to the 0 power, what will we get? Okay, so then b to the x, that becomes 1. What's 1 times a? 1 times a is 0.
0.
1 times 0. A is 0.
A times 1.
A is 0. So
1A.
1a or just a, right?
Oh,
So that's where we get, when x is 0, we get a for the value. So whatever value a is, if we plug in 0 for x, we're going to get our value of a. Alright. Then, b, my voice just did something weird. B is the common ratio. I'm going to show you something that might jog your memory. All right, so this is the general formula that we used when we were using geometric sequences, right? A sub 1 was our first term, R was our common ratio, and then N was whatever term we were asked to find, right? Does this look sort of like what we have now? What are some similarities that are close to that. Malcolm?
The A and the B.
Okay, so A sub 1 is just A now, we just don't have the sub 1 part, right?
Then the R would be the B.
Right.
And the N would be the X.
Exactly, so we're basically using the same things that we have been using with geometric sequences, we just switched the letters and renamed them something different. So it's A, B, and X instead of A sub 1, R, and then N minus 1. Okay?
So what if we can put in our notes then off to the left of where it says A is the value when X equals 0? What would A always be then? What is, A sub 1 is the what?
First number.
First number, so we could say A is always gonna be our starting amount, right? It's always gonna be our starting amount. Let's put that in our notes. You can count on A being how much it starts at. Like yesterday's things you did. What did the chessboard start with? How many pieces of rice on the first square? One. So that was the starting amount, that was the A value. How about the pennies? What did that start with? 1 penny. So do you think what you did yesterday could be represented by an exponential function? Do you think the grains of rice grew exponentially? Do you think the pennies grew exponentially?
Yes.
They got really large pretty fast, didn't they? Larger than I bet you thought they were going to get. So that was actually exponential growth going on there. Okay, so
All right. So, does anyone have any questions before we move on? Okay, so if everyone will open your books to page 624, we're going to do a little example problem. Alright, then everyone has your book.
624.
624, 624. We're going to be doing the checked out problem at the bottom of the page. So check it out number 1. And someone read me what that question's asking. Seth, do you want to read what the checked out problem to us, please? On page 624.
The function f of x equals model the photograph inches after it and reduced by 25%. X times what is the width of the photograph after it's been reduced 3 times.
All right, thank you. So we're given the function, where'd it go? 8 times 0.75 to the x. And it says that this represents the size of the picture, or the width of the picture, after it's been reduced by 25%. So, before we start, what's our 8, or what's that 8 representing?
8.
Oh, 8, yeah, but that's our starting amount, right? That's what we said we're putting in our notes just now. What would this 0.75
B.
be? And that is our R, and that is the common ratio, thank you.
And then the X is that.
And then, yep, X is the M. So, it is asking us, or before we move on, why is this 0.75 and not 0.25 if it's getting reduced by 25%?
100% minus 25%.
it's true, you're right.
That's true.
Yeah, there's nothing funny about that, that's right.
The reason why this would be 0.75 instead of the 0.25, because when we take 8 times 0.75, we don't get a super small number, we just get like 6 point something. So instead of going by 0.25, we would get a really small number. We would get 2 for that. Instead of it just getting reduced by 25%, it would be reduced 75%. Does that make sense? Sort of.
It's the multiplier, remember, common ratio is a multiplier. So it's gonna be 75% as big if we're reducing it by a quarter. Okay, so it's gonna, we have to multiply it by the 75% change to a decimal rather than 25% change to a decimal. What would we be reducing it by if we multiply it by 25% change to a decimal? How much would we be reducing it by? 75%. We would want 3/4 of its size reduced, right? Okay, we need to just go up above a little bit there and fill in some blanks, Mr. Conlon.
Mm-hmm.
When we're evaluating exponential functions, we need to follow blank, blank, blank. Order
Of
of operations. We have to follow order of operations, fill in the blank. Kind of got lost there. Follow order of operations. And that's what you're gonna have to start doing here shortly, so we gotta make sure we have that there, okay?
All right. So this question is asking us how big this picture will be, or the width will be after we reduce it 3 times. So 3 would go in for x, because that's how many times we're reducing it, right? So you can just rewrite it as 8.75 to the 3rd power. All right, and someone, what is 0.75 taken to the 3rd power?
This would be where we'd have to look at this question though. If we're gonna follow order of operations, what gets done first? Do we multiply 8 times 0.75 first,
Oh, no,
and then cube it?
no,
Or do we take 0.75 and cube it?
B and then B times 7,
Yeah, we gotta do the power first, don't we?
yeah.
That's why we have to remind ourselves, follow order of operations, and trust me, students don't oftentimes. They think, oh, I'll multiply first, that looks easier, then I'll take it to the 3rd power.
Cameron?
0.44 to 1.875.
75.
And we are gonna write down everything our calculator gives us on this, okay? No rounding here. No rounding, so write down what the calculator says when you take 0.75 to the 3rd power.
Nope.
So that's the different part.
Yeah, that's the different part. All right, then, what is 8 times 0.421875?
3.075.
This equals 3.375, you said?
Yes.
Is that all our answer is gonna be?
No.
Yeah.
Why wouldn't it be, Smart? Nope, we're not gonna round, but we're still missing one part of our answer.
Oh, the f of x, then.
Well, we can certainly write that, but there's still one more.
Well, I think first of all, what we need to explore is what is f of x representing?
Y.
Okay, and what is y representing? F of x, okay, and what is f of x representing?
Y.
We can go back and forth here all day, I don't care, you're just giving your homework time. F of x equals y, y equals f of x, what else? In this problem, what do you get when you get f of x or you get y? You get the width of the photograph, right? Oh, huh. So now that we know f of x is 3.375, that is representing the width, now we should be able to say, what's its label?
Oh,
Starts with a 9.
I wonder if
Some
there's,
people say it.
inches.
is there anything in your reading there that would have helped you get that answer?
So if we go back to the beginning of the problem, we start with a picture that has a width of 8 inches. We reduced it by 25% 3 times, so now its new width is 3.375 inches. All right. So now we'll move on to number 2. And you guys can do this one by yourself.
How about not until we decide what everything in it is representing?
Okay.
What is it? So it says f of x equals 500 times 1.035 to the x power models the amount of money in a certificate of deposit after x years. So what does f of x represent in this problem?
Money.
Oh, money?
Inches.
Just money.
Six.
Malcolm, don't try and be funny because it's not working for me. This problem doesn't have anything to do with inches and you know it.
I thought we saw that.
What does FFX have to do with, what's it representing from? Money what?
Money.
Amount of money.
Amount of money what?
A year.
And a certificate of deposit.
That you're gonna have after a certain amount of
Yeah.
time, yeah, after a certain number of years.
After 6
okay?
years.
So when you are supposed to find it after 6 years, where would you be plugging the 6 in?
The X.
For the X, okay, now he can let you work on your own.
Would we still be minusing the exponent by 1 or?
This formula doesn't have that subtract one. We'll explore that maybe if we get a chance here. Why don't we subtract 1? Yeah, just do this. Oh, wait a minute. Money.
Hold, hold on, the teacher is empty.
Make collateral.
Mhm. Just go to the 2 as far as the 2 goes.
Well, no, you don't get to
So
shoot
you can't
already.
get to the 6, right?
They didn't say.
Okay, so
This $500.
see that?
$500 to make it a deposit to start with. How much was this CD worth at the beginning?
614.
No, how much was it worth at the beginning?
Beginning, 500.
No, $500. It was a $500 CD. Anybody think they can tell me what was the interest rate on this CD? How much interest were they paying them? Josh? Okay, and what interest rate would that be then? What percent would that be? How much percent were they getting paid for this CD? About 1%? No, they were getting more than that.
4%.
Almost 4% maybe. 3.5%. And that'll be something we'll learn more of. I just want to see how well you can do with that, okay?
Alright, so did everyone get 614.67, so on and so forth? Would that be our answer then?
No, dollars.
Years.
Right, Shamarky said it. Because what is this function representing, or what should we find if we plug in x values?
How much money will be in 6 years?
Exactly, so after 6 years, we should get $614.63.
When it's money, we'll round to the nearest cent, okay? So that's 7, makes it 63 cents rather than keeping it 62, right? So how much money have they made on this CD in 6 years?
614.
No, how much money have they actually made? $114.63. It started out as a $500 one, right? So they've made $114.63 on it in 6 years, yes.
I thought the dollar sign was 5.
Oh, you thought that was a 5 there, yeah, I see.
I'll make it look better.
Maybe he should just not put the equal sign there.
Yeah.
You can just put the money at that point. Okay.
Sure.
There we go. All right. Does anyone have any questions before we move on to the next page? Alright, so number 3, function f of x equals 200,000 times 0.98 to the x, where x is the time of years, models the population of a city. So what is this function representing? Or what should we get if we plug in x values?
The populations and.
Well, just the function. Let's forget about the 7 years just for now. If we plug in any value into that function, what would we get
For x.
for x?
Find out about time.
Yep, we would get the population for how many years, exactly. So, now that we know what it is representing, now we can figure it out for,
What does population start at?
200,000.
200,000 people. By the way, what do you think, looking at that common ratio? Let's use some reasoning here. Do you think the population is gonna get larger or smaller?
Smaller.
Why is it gonna get, I heard smaller, louder. Why is it gonna get smaller, Josh?
It's less than 1%.
We're multiplying by less than 1, aren't we? Isn't that the multiplier, 0.98? That's our multiplier. Well, it's less than 1. What happens when you multiply by something less than 1? It gets smaller, yeah. So this population should go down. So we need to do some reasoning, not just plug in numbers and know how to use our calculators. That is not good enough for me, sorry folks. Now you can use your calculators in the formula. Some of you aren't doing your own work. That's not going to be very helpful when you got to do it on your own. You're not going to get any help from me either, or Mr. Conlon.
all right, so it looks like everyone got to this answer, 173,625.1066, right? Is that our final answer? No? Because what are we dealing with in the function? Do we have 0.1066 of a person? Yeah, we can't really do that, can we? So we would round to the nearest whole number because we can't have a fraction of a person. That's kind of sketchy, isn't it? So our final answer will be people. What does that number 173,625 mean
Population.
after? Yes. Cameron?
My calculator put the 1 on the other side of the decimal.
Which one?
For before we rounded it to the nearest whole person.
Mhm.
My calculator put the 1, the decimal, behind the 1.
Then something went wrong, what you did.
Yeah.
You might have typed in an extra 0 then when you were multiplying on the 200,000. Did what we expect to happen happen? What did we expect to happen again?
Population.
Decrease,
The population would decrease. Did it decrease?
yes,
Yeah, so we feel like our answer's pretty good then, don't we?
yes.
Okay.
All right. So last one, number 4. First things first, what's this function representing?
You want to 7 years?
Height,
Oh, wait, no, I'm sorry.
Yeah. If a golf ball's dropped from a height of 30 feet, function f of x equals 30 times 2/3 of the x. The height of each bounce in feet, where x is a number or bounce number. Yes, Brighton?
Did we turn the 2/3 to 0.66?
No. you could not, because that goes on forever and ever, right? 0.66 repeating is what 2/3 is, so we can't plug that into our calculator, can we? It's not enough room in the calculator, so when you do this, they know how to do the 2/3.
Okay, well, if they don't have it, they don't know how to use a fraction key in their calculator, I don't teach them how to use it. What they can do instead is, you remember how can we do fractions? We can say 2 over 3 means 2 divided by 3, right?
Mhm.
So we can do parentheses, 2 divided by 3 parentheses, and then take it to the power that you're going to take it to, okay? So either you know how to use a fraction key in your own calculator, I'm not going to show you how, or you use my way, which is parentheses 2 divided by 3 parentheses.
All right, so, I'm not sure if I got an answer to this, but what is the function representing again?
Not the f of x.
The f of x representing what should we find when we plug in values for x?
What am I?
Hmm?
What am I?
What the height of the golf ball will be after it bounces, right, so,
Okay, let's actually do that, let's underline that in our notes, okay? Because this is a lot of reading, so let's underline f of x and then height of feet of each bounce. Underline that. Circle it, something, so that you know when you get that f of x value, what is that really telling you? And then you can decide if it seems to make sense to this problem, okay? Because what do you think we should expect to happen in this one? Drop from a height of 30 feet. Should we get an answer higher than 30 feet in the end?
No.
Probably not. Okay.
all right, you guys can start doing it. Why is it writing double?
What is x representing in this?
Height,
Nope. Not, well, x can represent any bounce number, right? Whether it's the second bounce, the sixth bounce, whatever bounce it is, x is representing the bounce number.
bounce number.
Yeah. Oh, that's okay. So just now taking the fourth power. Okay. Oh, that's cool. Write down that big long number your calculator gives you, whatever it gives you, you're writing down. I don't care how long it is.
Two, 5, 9, 2, 6. 9, 2, 6.
Thank you. All right, so I think everyone's done. So did everyone get 5.925, 925, 926? All right. So is that our final answer? Nope. Needs a label, doesn't it? If we're dealing with height and things, so this would be, first off, could we round?
Yeah.
Yeah, so let's round
What
it.
does it say to round to?
Nearest tenth. Eight.
I was afraid you were gonna pick something else and already told him what you
No.
wrote. Sorry.
5.9, and what are we measuring in? Feet, so 5.9 feet.
Okay, I have to ask you a question. What does that 2/3 actually represent? What's happening? What does 2/3 mean in that problem?
.666.
Yeah, that's another name for it. That isn't what it means, that's another name for it.
Oh, man.
What do you think, Brayden?
Doesn't it mean on how much or how high it bounces the next time, like, maybe it won't reach whatever it was before, but it'll be lower?
And how much lower would it actually be? It got, how many times as high? Came back 2/3 of what it was, right? So it was 30 feet before, and when it got dropped, it says the bounce is going to be 2/3 of that height. And then the next bounce will be 2/3 of that height, and then the next bounce will be 2/3 of that height. So does our answer seem reasonable?
Yes.
Yes, it does.
Alright, so does anyone have any questions about what we went through today? No? Right on. And I will pass that over to assignment.
I'll get your handouts for you. The worksheet that you do.
Nope.
Oh, this is not, you don't know the machine thing? You want the machine too?
No, mine would be more valuable.
Alright, so,
Nice job.
oh yeah, I forgot to do that.